You're welcome to today's class. You're welcome to today's class on Mathematics for Economists. The topic we'll be looking at is Crammer's rule. We'll be looking at Crammer's rule. In Crammer's rule, this is when you are solving a linear equation using determinants. Then we say that you are involving what you know as Crammer's rule. How do we use determinants to solve linear equation? The formula states unknown variable equals to special matrix divided by determinant of coefficient matrix. Now we say that the unknown variable, which is this, equals to special matrix divided by determinant of coefficient matrix. Now let's move to example 1. Solve the system of equation below using Crammer's rule. Now, example 1 says solve the system of equation below using Crammer's rule. 6x subscript 1, which is 6x1, plus 5x2 equals to 49. 3x subscript 1 plus 4x subscript 2 equals to 32. Now the solution to it. Now, the first thing is to determine the determinant of coefficient matrix, which should now give us this 6 here, then we have 3 here. So we have 6, 3. Here is 5 plus 5x2, 4x2. So we have 5 for the x1, x2, then the answer value equals to, what is the answer value? 49 and what? 32. 49 and 32. 49 and 32. Now we look for the determinant of A, the determinant of x1 and the determinant of x2 before we can now solve for our x1 and x2. So the determinant of A equals to, using this, we now say which equals to this times this or this times this, that will be 4 times 6. The invisible minus at the middle, then we have 3 times 5, which equals to 4 times 6, 24, minus 3 times 5, 15, which equals to what? 24 minus 15, which will now give us 9. Then the determinant of x equals to, if you are looking for the determinant of x, the 6 and 3 here, which represent x1, the determinant of x1, which represent x1, this one represent x2. You have to replace it with the answer value, which is 49 and 32. 49 and what? 32. Then we have 5 and 4. 5 and 4. Then we can now say the determinant of x1 equals to 4 multiplied by 49 with the invisible minus, and then 32 times 5, which equals to 4 times 49, 4 times 9, 36, carry 3, 4 times 4, 16, plus this, 196, minus 32 times 5, 5 times 2, 10, carry 1, 5 times 3, 15, plus 1, 160, which equals to 196 minus 160, 36. Now that we have gotten 36, we can now move for our x2. Our x2 equals to the determinant of coefficient matrix of our x2 will be, we have the determinant of our coefficient value for x2 will be, this is 6, 3, this is for x1, so we maintain it, 6 and 3, while for our x2, we replace this with the answer value, which is 49 and 32, which equals to, we now say, 32 times 6 minus 3 times 49, which equals to 32 multiplied by 6, 6 times 2, 12, carry 1. 6 times 3, 18, plus 1, 192, minus 3 times 49, 3 times 9, 27, carry 2, 3 times 4, 12, plus 2, 14, which equals to 192 minus 147 will give us 45, because 2 minus 7 possible. Borrow 1 from this 9, we have 8, then this will be 12, 12 minus 7, 5, 8 minus 4, 4, then 1 minus 1, 0. So we can now say that x equals to the determinant of x1 all over the determinant of a, which equals to the determinant of x1 is what? 36 divided by determinant of a, which is 9, which equals 36 divided by 9, 4. While our x2, that is x1, x2 equals to determinant of x2 all over determinant of a. Determinant of x2 all over determinant of a equals to, determinant of x2 is what? 45 divided by determinant of a, which is 9. 45 divided by 9 will give us 5. So this is our answer for S1 and S2. To verify if our answer is correct, let's go back to the question. The equation 1 of the question, which says that x1 plus 5x2 equals to 49. Let's see if we can get this 49 by replacing our s1 here with 4 and s2 here with 5. 6 in bracket s1, 4 plus 5, s2, 5. 6 times 4, 24, plus 5 times 5, 25. 24 plus 25 will give us 49. So, which is the same with this. That shows that we are correct. We can move further to example 2. For example 2 says that EG2 solve the system of equation given below. Solve the system of equation given below. 4x1, 2x2, 6x3 equals to 28, followed by 3x1 plus x2 plus 2x3 equals to 20. The last one, now, the last one is 10x1 plus 5x2 plus 15x3. I'm using s2, s3 for convenience. It's 10x subscript 1 plus 5x subscript 2. So solution. Now the coefficient of the determinant of coefficient matrix here will give us 4, 3, 10, 2, 1, 5, 6, 2, 15. Then we have x1, x2, x3 equals to the answer value. The answer value is 28, 20, 70. 28, 20, and 70. Now we now look for the determinant of x1. Determinant of x1 equals to, we use only this to get our determinant of x1. So using this, when you pick 4, then you cancel what are the same row and column with 4. We have 1, 5, 2, 15. This will be positive, negative, positive. So negative, you pick the next one, 2. You cancel what are the same line and column with it. 3, 10, 2, 15. The last one, plus 6. You cancel what are the same line and column with it. You have 3, 10, 1, 5. Which determinant of determinant of A, I put x1 here, is A. So the determinant of A equals to 4 in bracket 15 times 1, 15 minus 5 times 2, 10 bracket close minus 2 bracket open, 15 times 3, 45 minus 10 times 2, 20 plus 6 bracket open, 5 times 3, 15 minus 1 times 10, 10 bracket close. Then you now have the determinant of A equals to 4 in bracket 15 minus 10, 5 minus 2 bracket open, 15 minus 45 minus 20, 25 bracket close, plus 6 bracket 15 minus 10, 5. Then determinant of A equals to 4 times 5, 20 minus 2 times negative 2 minus 2 times 25, 50, plus 6 times 5 here. 6 times 5 here will give you 30. 20 minus 50, negative 30, plus 30, the determinant of A equals to 0, which shows that it does not exist, a vanished result. So we cannot move further since we have gotten our determinant of A to be 0. If we move further and solve for S1, S2, and S3, our final answer will still be 0, 0, 0. We move to example 3. In our example 3, we look at this question. The question says, solve the system of equation below using Crammer's rule. 3x plus 2y plus z equals to 10, 2y plus 3z equals to 20, x minus y plus 2z equals to 5. This is the question. Solve the system of equation given below using Crammer's rule. 3x plus 2y plus z equals to 10, 2y plus 3z equals to 20, and x minus y plus 2z equals to 5. Equation 1, 2, and equation 3. Now, let us determine the determinant of coefficient matrix. Solution. 3. This is not having x, so it will be 0, 1, 2. This is y here, 2. Remember, this is x, y, z. This one will be z here. So y here, -1. This is minus y. That means minus 1y. So it's -1. Z, 1, 3, 2. We have x, y, z equals to the answer value 10, 20, and 5. Now we want to look for the determinant of A. The determinant of A equals to, we use this only to look for the determinant of A. Just like as we have solved in the last equation, we now says 3, this one here, which carry positive sign, negative, positive. 3, we now have, cancel what are on the same line, 2, -1, 3, 2. We now have -2. Then if we cancel it, we have 0, 1, 3, 2. We have +1. If we cancel it like this, we have 0, 1, 2, -1. So the determinant of A equals to 3 in bracket 2 times 2, 4, the invisible minus. -1 times 3, -3, bracket close, -2, bracket open. This times this, 0, -1 times 3, 3, plus 1, bracket. 0 times -1, 0, the minus, 2 times 1, 2. Which determinant of A equals to 3 in bracket 4, minus times minus, plus 3, -2, bracket. This one, -3 plus 1, bracket. 0 -2, -2. So which our determinant of A equals to 4 plus 3, 7. 3 in bracket 7, minus times minus plus 2 times 3, 6. That will give us +6, plus 1 times -2, -2. Which our determinant of A equals to 7 times 3 times 7, 21, plus 6, -2. Which our determinant of A equals to 21 plus 6, 27, -2. We have 25. Now that we have 25, we can now move on to our x, determinant of x. So solving for determinant of x, the determinant of x equals to, we have this is x, 301 represented. So we now replace it with the answer value, which are 10, 20, and 5. 10, 20, and 5. Then we have 2, 2, -1, 2, 2, -1, 1, 3, 2, 1, 3, 2. Now the determinant of x equals to, the same way we did, we apply here. So we have 10, 2, -1, 3, 2, -2. So we have 25, 3, 2, then plus 1. We now have 25, 2, -1. So which, when we pick them, we cancel what are on the same row and column with it. We have this. When we pick 2, remember here is negative, positive, and negative. We cancel it like this, so we have this. When we pick 1, we cancel it like this, and we have this. Then we now say determinant of s equals to 10 in bracket 2 times 2, 4. There is invisible minus. Say the invisible times minus here will give us plus 1 times 3, 3, -2, bracket. 20 times 2, 40, minus 15, plus 1 in bracket. -1 times 20, -20, -10. S equals to 10 in bracket 4 plus 3, 7, -2, 40 minus 15, 25, plus 1 bracket, -20 -10, -30. Which the determinant of S equals to 10 times 7, 70, -2 times 25, 50, plus times minus, -30. Which the determinant of S equals to 70 minus 50, -20. -20 minus 30 will give us -50. So this is our determinant of, this is our determinant of x. So we now look for our determinant of y. Determinant of y equals to, let's get our determinant of coefficient matrix. So we have 3, 0, 1, 3, 0, 1, 3, 0, 1. We are looking for y, so we replace this with the answer value, which are 10, 20, and 5. Then we have 132, 132. Then we now look for the determinant of y. Permit me to clear this up. So, looking for the determinant of that, we now say the determinant of y equals to what we have here. We apply the same thing where we now say 3. Then we have, when we cancel it like this, we have 25, 32 minus 10, which we have, when we cancel it, is 0, 1, 32 plus 1. Then we cancel it like 0, 20 and 1 and 5. 0, 20, 1 and 5. Now, we now say the determinant of y equals to 3 in bracket 20 times 2, 40, minus this times is 15, minus 10, this times is 0, minus 3, plus 1, 0, minus 20. Which the determinant of y equals to 3 bracket, this minus is 25, minus 10 bracket, this minus is negative 3, plus 1, 0 minus 20, minus 20. Now, determinant of y equals to 3 times 25, 75 minus negative times negative plus 10 times 3, 30 plus x minus this one will give us 20. So determinant of y equals to 70 plus 30, 105. 105 minus 20. 105 minus 20 will give us 85. That's our determinant of. So we now move on to our determinant of z. In z determinant, that is why I don't want to clean here well first. So we first get the determinant of coefficient for z. In here we have 3, I think so, is 3, 0, 1, 2, 2 minus 1, 2, 2, negative 1. So 132 we now replace it because it's for z, so we can rub it now. We now replace it with the answer value, which are 10, 20 and 5. So now we can now say the determinant of z equals to 3 in bracket 2, negative 1, 25 minus 2, 0, 1, the way we have it the other time, 25, then plus 10, the way we have it too, 0, 1, 2, negative 1. So the determinant of z equals to 3 in bracket 2 times 5, 10, minus times minus plus 20, 1 times 20, 20, minus 2, 0 times 5, 0, minus 1 times 20, 20 plus 10 bracket 1 times minus 0, 0, minus 2, because 1 times 2 is 2. Z equals to 3 in bracket 10 plus 20, 30 minus 2, this minus is minus 20 plus 10 bracket, this minus is minus 2. Z, determinant of z equals to, this times this, 90, minus times minus, plus 40, 2 times 20, 40, plus times minus, minus 10 times this, 20. The determinant of z equals to, this plus this, 130. 130 minus this will give us 110. Now we have gotten our determinant of z. Now, from our solving, we say our determinant of a equals to 25. The determinant of s equals to, I think, 85. Our determinant of s negative 10, y 85, and our z is 110. Our z equals to 110, as we have them in the answers we got. So determinant of x equals to, sorry, x only equals to determinant of x all over determinant of a, which equals to determinant of x negative 10 all over 25. So this here 2, 5 here 5, which equals to negative 2 all over 5. Our y equals to determinant of y all over determinant of a, which equals to 85 divided by determinant of a, 25. 5 here 5, 5 here 17, 17 all over 5. While our z equals to determinant of z all over a, which equals to z 110 divided by what? 25. 5 here 5, 5 here 2, carry 1, 5 here 2, which equals to 22 all over 5. This is our final answer. Thank you. So this is our final answer. We have negative 2 all over 5, 17 all over 5, and 22 all over 5. Our x give us negative 2 all over 5. Our y give us 17 all over 5. While our z give us 22 all over 5. So normally, if we want to verify the answer the way we used to verify it, we will still apply it that, okay, x minus y, picking any of these equations, we can now say x minus y plus 2z equals to 5. When you pick it, this equation 3, now you want to get this 5. So when you put your x, which is negative 2 all over 5, minus your y, 17 all over 5, plus 2z, 2 in bracket, 22 all over 5. When you solve this, you will see how like negative 2 all over 5 minus 17 all over 5 plus 44 all over 5. So you still have it like this as 5. Then you still have what? Negative 19 plus 44. When you solve this, what do we have at your final answer? What we get at your final answer will still, like this, negative 19 minus 24 will give you what? 25. Divided by 5. 5 here 1, 5 here 5, which equals to 5 that you got here. So which shows that the answer is correct. Thank you.